All right. Good morning, everyone. Thank you so much for joining our webinar today. My name is David Kalmbach, Head of Technical Solutions and Support at Framos, and I'm thrilled to be your host for this session. At Framos, we are dedicated to making latest imaging technology easily understandable and accessible. With that, we are supporting our clients to excel in building innovative imaging solutions of tomorrow. For today, I'm excited to have our long-standing partner Sony joining us to share insights on optimizing advanced Sony sensors in agriculture. I'd like to welcome you joining us for a walk through core requirements towards image sensors in agriculture applications. Furthermore, we're going to learn about how Sony tackles these requirements for various sensor families and which features and performance characteristics best to utilize for our optimizing outcomes. Let me kindly introduce you to our speakers for today. Alex, Business Development Manager at Sony Semicon EU, Giuseppe, Technical Imaging Expert at Framos, and as a special guest for today, we have Axel, Managing Director at Restore Framos, joining the round. I'm looking forward to all of them providing their expert perspective in today's discussion. Here's a quick look at our agenda for the webinar. Right after my short introduction session, I'll hand the mic over to Axel, who is going to introduce Restore Framos to you and explain how the company is connected to the Sony Framos collaboration. Axel will then hand the mic over to Alex, who will speak for about 15 minutes about advanced Sony sensor features for agriculture and how to optimize sensors for tough outdoor conditions. Giuseppe is going to follow up, explaining how Restore Framos and Framos together support enabling customers to create imaging solutions around the mentioned image sensors. After about 25 minutes in, we'll wrap things up with a 5-minute Q&A session where we'll address your questions and provide additional insights. Before we dive in, I'd like to highlight the question feature in this webinar platform. Please use this icon to raise questions during the webinar. Questions will be tackled during the Q&A sessions. For any unanswered ones, we'll come back to you soon after the webinar. Now, without further ado, let me hand it over to Axel from Restore Framos to kick things off.
Hello, good morning. My name is Axel Kreppel. I'm Managing Director of Restore Framos, and you might be curious to see why are there, let's say, 3 companies presented here, Framos, Sony, and Restore Framos, what you have not seen before. Since 1st of October, there's a change in the organization here. So Restore Framos Technologies took over the Sony franchise of the image sensors, while Framos still is maintaining all the, let's say, applications, the image sensor modules and the technology around that. So Restore Framos is the successor of the company Vimos Technologies, which was part of the Restore Framos group, and it was renamed 1st of October to restoreframostechnologies.com. We are based here in the Munich area. We are still, since about 9 years or so, we are a technical distributor. We were connected to Framos very, very well in the past, and that's the reason why we now taking over, or why we took over the Sony franchise as a technology and distribution partner for Sony. Here you see how we are working in the future. Framos is definitely the partner for you guys if you want to have sensor modules, FSM2Go, IP around all these sensors there. And when you are interested in a real sensor, when you don't want to buy, or when you are not in the need of an image sensor module, you want to buy the pure imaging sensor, then you come to us in Restore Technologies. We also have application engineers, we have technical imaging experts, and we also can support you very, very well in terms of all your requirements and needs. Next slide. Yeah, here are our contacts. restoreframostechnologies.com. You will find us in the internet as well, and you will see that we are not only a distributor for image sensors. We also have, since about 10 years, we also have other components. If you're interested in them, please visit our website and see what is there available for you. We also have power management ICs for image sensors, for example. We have a little bit of wireless. We have memories dedicated for, let's say, AI cameras. We also have passive components like optics and lenses. So feel free to have a look there and contact us if you want. Thank you.
All right, thanks a lot, Axel. And then let me hand it over to Alex from Sony.
Yeah, thanks, David. Also, warm welcome and good morning to everybody who is listening and watching today from my side. Let me briefly introduce myself. My name is Alexander Papst. I'm Business Development Manager at Sony Semiconductor Solutions Europe. And over the next 50 minutes, I'll walk you through the specific visual challenges that farmers and agricultural technologies companies face in outdoor environments, and more importantly, how Sony's sensor technology is addressing these challenges. We will explore three interesting sensor technologies: our IMX 900 global shutter series, our Starvis sensors with enhanced NIR or near-infrared capabilities, and our very new IMX 454 multispectral sensor. So I would say let's dive in. No, that works. Okay. So first, let me set the context. Why do image sensors actually matter in agriculture? And I think the keyword here is precision agriculture. Precision agriculture is fundamentally transforming how people farm. It's no longer about really treating the entire fields uniformly. Instead, precision agriculture enables data-driven decisions for crop monitoring, disease detection, and most importantly, yield optimization. We're talking about really the ability to identify problems at the individual plant level to optimize water and fertilizer use, and also to predict yields with good accuracy. And yeah, this global precision agriculture market is experiencing significant growth, and this is mainly driven by three critical factors. First, really the need for increased productivity on the field. Secondly, sustainability, and third, resource efficiency, which is also a key factor which is important in the future. And on the other hand, there are of course also challenges which we are talking about when we're talking about visual sensing in those, let's say, tough outdoor farming environments. Those are really incredibly demanding, and you're dealing with variable lighting conditions from harsh midday sun to overcast skies to dawn and dusk operations. You're facing really harsh weather conditions. And lastly, you of course need reliable data capture. And this is where image sensors really become absolutely critical. They're really key enablers that provide high quality, actionable visual data for smarter, more efficient farming. And Sony offers actually those image sensors which enable precision agriculture. And I would like to show you how. Let's start here with our IMX 900 global shutter sensor. This sensor incorporates, I think, three key features that make it exceptionally well suited for, let's say, agricultural applications. First, NIR enhanced sensitivity, or near infrared enhanced sensitivity. So near infrared imaging is crucial for agriculture. Why? Because plants reflect near infrared light very differently than visible light, and this difference reveals critical information about plant health and stress that you simply cannot see with the human eye. And our IMX 900 offers really improved performance in the near infrared range, which also means better imaging in low light conditions and during dusk and dawn periods. Second, improved G-Fray angle, or in short, CRA. The G-Fray angle determines really how flexible you can be with lens selection and system design. With an improved CRA, the IMX 900 supports compact and wide angle optics without significant image quality loss. And this means you have much greater flexibility in how you design your camera systems, whether you're building kind of a compact drone mounted camera or a wide angle system for a harvester. The IMX 900 can accommodate your lens requirements without compromising the image quality. And third and lastly, quad HDR technology. This is a quad HDR technology really captures several exposures per frame for the sensor, really delivering exceptional dynamic range for a global shutter sensor, which has not been on the market before. I think about this kind of following challenge in a single field, you might have bright sunlight reflecting off a light-colored soil while simultaneously needing to see detail in the shadows of plant. And that's kind of a big dynamic range challenge. And traditional sensors would either blow out the highlights or lose details in the shadows. And the IMX900's quad HDR really maintains image quality across these diverse lighting conditions. As you can see here in this comparison, the IMX900 really represents a good step forward. The improved CIA, as I mentioned, gives you more design freedom, and the enhanced NR sensitivity really ensures you capture the information that matters most for crop analysis. And this combination of features makes the IMX900 a good choice for agricultural applications where blur-free imaging, flexible system design, and challenging outdoor lighting conditions are really the norm. Now let's move to our Starvis sensors, which take a different approach to solving agricultural image challenges. So Starvis technology originally was developed for security and surveillance application, but we discovered that many of its features are incredibly valuable for agriculture as well. And let me explain why. Again, those sensors really offer an increased and very exceptional NR sensitivity. And if the IMX900 series is good at NR, really the Starvis sensors are exceptional or better, or really better here. And this increased sensitivity really supports better visibility in low light conditions, which is then also critical for extended operational hours. With Starvis sensors, you get really consistent high quality images for crop monitoring with real robustness to lighting conditions. Then there is an interesting feature which we call DOL HDR or digital overlap HDR. So this is a different approach to high dynamic range than what we use in the IMX900. Instead of really capturing multiple exposures sequentially, DOL HDR simultaneously captures multiple exposures with a slight temporal overlap. And this reduces really motion artifacts and maximizes detail. And in agriculture, you're often dealing with movement and wind, for example, moving plants, the camera system itself moving through a field, or equipment vibration. And really the digital overlap HDR ensures you get clear and detailed images even with moving equipment or rapidly changing lighting conditions. And this is really particularly important for applications like sprayer guidance or real-time weed detection, where the camera is constantly in motion and you cannot afford blur or artifacts in your images. And lastly, clear HDR functionality. This is a different target here. So clear HDR really maintains color fidelity and detail in scenes with both bright and dark areas. And this is just not about capturing a wider dynamic range. It's really about maintaining accurate color representation across the entire range. Because many crop health assessments and disease detection algorithms rely on precise color measurements, and this is important. So if your HDR processing distorts the colors, eventually the analytics might become unreliable. This graph shows you the quantum efficiency actually across different wavelengths. As you can see, the Starvis sensors here in green, the green curve, offer overall the best quantum efficiency over the detectable wavelengths compared also to other Sony sensors. So for example, here you can also see the IMX900, which I mentioned before, which is the pink curve. And even in the NR region, you really see kind of a big gap still between those two sensors. And eventually that kind of combination of superior low light performance, motion resistant HDR, and excellent, let's say, NR sensitivity makes Starvis sensors a good choice for many agricultural applications. Now I need to switch the slide, but it's, yeah, no, perfect. All right, now let me introduce you to something completely new, which is the IMX454 multispectral sensor. So the IMX454 multispectral sensor captures 41 distinct wavelengths ranging from 450 to 850 nanometers, and this is done within a single shot. The sensor uses 8 multispectral filters arranged in a sophisticated pattern that allows for comprehensive spectral sampling across the visible and really the near-infrared spectrum. This enables detection of subtle color differences and material composition that are beyond human vision. And we are talking about seeing biochemical properties of plants there, detecting stress, identifying material composition at the same time. So this is quite a powerful device here. The multispectral data captured by the IMX454 can be processed also intelligently. The sensor includes optimized functions for defect correction, noise reduction, and auto exposure. It also supports semantic segmentation, which means precise material identification, and the sensor can generate standard color images from the multispectral data while simultaneously providing full spectrum analysis. Anyhow, this type of processing needs to be done externally on a CPU or an FPGA. You can tailor spectral bands on your specific or to your specific crop or soil analysis needs. Different crops have different spectral signatures, different diseases show up in different parts of the spectrum, different soil conditions affect different wavelengths. With the IMX454, you can optimize your spectral analysis for your specific application. This reduces really the need for multiple cameras. Instead of having one camera for RGB, another one for NIR, and perhaps another for specific band analysis, you have only one sensor, and this really streamlines system design and significantly lowers the cost of the system. Now, let me show one of the most compelling applications. If the slide's changing now, which is green-on-green detection and in agriculture. So this is really kind of the holy grail in precision agriculture. Basically, that means how do you distinguish between crops and weeds when they're both the same color in green? So this is really a challenging application, and the IMX454 really here enables comprehensive crop health monitoring and advanced analytics, including also machine learning for disease prediction. Spectral resolution outputs closely reflect the true spectral characteristic of the objects eventually. And here's how this works in practice. So the system utilizes pre-collected spectral data sets of target objects and light sources to determine optimal reconstruction parameters for each specific use case. You're essentially training the system on to recognize the spectral fingerprints of crops versus weeds, or healthy plants versus diseased ones. And this approach is especially effective for applications requiring fine spectral discrimination, and that's how distinguishing between crops and weeds or green-on-green detection becomes really more reliable and also accurate. So now, having the right sensor is I think just the starting point. I would like to also to finish off my keynote here, I would like to share some practical optimization tips to help you to get the most out of these sensors in really tough outdoor agricultural conditions, right? So the first point might seem very obvious to you, but I want to mention it anyway, but because it's critical. Match really the sensor features, whether that's NIR sensitivity, HDR capability, or the need for multispectral imaging to your specific agricultural application. Really ask yourself what I'm trying to detect, what are my lighting conditions, what's my operational environment, am I on a moving platform or am I stationary? Do I need real-time processing? All those factors you would need to take into account when designing a system in the end. The answers to these questions will really guide you toward the right sensor choice, and there's no, let's say, one size fits all solution. But with Sony's range of sensors, I think we will try to find the right solution here for you. Also, utilize sensor functions. These sensors really have advanced functionalities built in, and make sure you're taking full advantage of them. So really use global shutter for blur-free imaging when you're on moving platforms, leverage the quad HDR functionality of IMX900, for example, or digital overlap HDR for really capturing high contrast scenes in variable outdoor lighting. Take advantage of the improved CRA capabilities of some sensors for flexible lens options that match your form factor requirements. And here's also something people often overlook, are try to adjust your sensor settings dynamically. So exposure, gain, HDR mode, these shouldn't be set once and forgotten. Optimize them based on varying outdoor conditions, lighting conditions, or operational conditions. As calibration is also a topic, especially for the IMX454. Especially for this sensor, calibration is essential for consistent, reliable data, and spectral measurements need reference standards here. And lastly, or finally, think about system level integration for seamless and hardware and software performance. The sensor doesn't operate in isolation. Really consider your processing pipeline, your data storage and transmission, your power budget and your thermal management. In agricultural application, environmental factors, dust, moisture, temperatures, extremes, vibration, all affect system performance, and really design your integration with these factors in mind from the beginning. And that's where our partner Framos comes into play, who can really assist you to design the perfect system for your needs. That's why I want to now hand over to Pino from Framos to show what they can do.
Yes. Next slide is coming. First of all, thank you everyone being here. Thank you, Alexander and Alex, to explain a bit how the organization is, and in special, so nice image sensors for agriculture. Now, I will spend a few minutes talking about how we in Framos can support and the implementation of the system as well. Alexander mentioned the system is important. The components are not isolated. And so here we in Framos and Restart Framos, we go from components to system. We will see. First, Axel mentioned, okay, the distribution of the sensor, the get access to the sensors, get the information about the sensor, and also what's coming next. This is very important when you have to plan your next production, your next project, maybe in few years in front of us. So it's very valuable, the support that Framos Restart can provide, giving access to all the information, but not only, even the management of the sensor and the warehouses is pretty complex, because of course image sensors are sensitive objects, and in case we also do stocking and have certified warehouses by Sony. So this is a guarantee of quality. So not only we mentioned how complex are the sensor, and also Alexander mentioned that there are so nice functions in it, and so the technical support on the sensor itself is very high level here in Framos Restart. Here I'm showing some typical questions that comes. This is the spectral sensitivity, and many times the customer asks about quantum efficiency. Today, Alexander shows a nice quantum efficiency curve, but all of this information and going into registers and know the sensor characteristics, the noise readout, and all of these things is the technical support that Framos Restart can provide, and provide actually to the customer, to really being able to use the sensor in the best way and use the functions in the best way. Now, of course, there are not only components, but the system matters here. And the system is also optics first. And here in Framos, we have optics expertise. And so we have access to optics and all the consulting that we can provide to select the right optics for your application, for the sensor that you are using, and managing also the customization of the lens. Here today we talk about multispectral or bands, and also the filters and all the equipment that you need really to being able to get the information that you need out from the scene, not only from the sensor, because the lens is the front end of the sensor and must be appropriated. And optics expertise is very not easy to find all around. We provide that support, and not only, we provide also embedded vision camera modules. Axel also mentioned at the beginning sensor module FSM Go. So we do a system integration, and this is done in two many different ways. One is kind of off-the-shelf modules with some pre-selected sensor and lenses, but this most of the time is the starting point to implement a custom or a tailored system with the sensor that we selected together, with the lens that we selected together, with the proper interface also, because system means also we need to transfer the information from the sensor to some host, to some software, and so the low-level interface of the sensor, MIPI, SLVSCC, and then the driver on some host that could be NVIDIA or embedded system like NXP or Qualcomm, or everything that you need to get the image into the memory. And most of the time, the image must also be calibrated and must be tuned. And so all the corrections that are needed, we also manage at the system level. So this means that we can provide objects, products, camera modules that are easy to be developed at scale for your production. So you see how from the components, from each small tiny details, we also can support the customer up to the complete system. So it's up to you if you want to focus and just get access to the sensor, or you want a full consulting and the system level. Here is what Restart Framos and Framos can support worldwide. So I think that this is an easy way to develop a new product, especially in agriculture, where everything is totally new or very new kind of application.
Okay.
So
thank you very much,
that's all.
Giuseppe.
Yeah.
Then also thanks a lot, of course, to Alex, our core speaker, as well as Axel for introducing Rest of Ramos. Now, there's plenty of questions that came in. Time is limited. We will probably do a few minutes more just to tackle most important questions. We will not probably get to answer all of the questions. For the other ones, please remember that we will come back to you shortly after the webinar. So let's get this started for the question session. Initial one is related to the IMX 900, I believe. Alex, if you can go back to these slides. And it's about the shading part in the sketch of the pixel structure. So can you explain better what is meant with that shading part in the pixel structure?
Yes, actually that's an electric isolation which prevents, or like which should prevent crosstalk between the different pixels to really get a better image quality or image data in the end. So that's kind of
like a deep
the shading
isolation.
Yes, yes.
Okay, thank you for that. Next one is related to, again, IMX 900 and the Quad HDR feature. And the question is about how the IMX 900 Quad HDR actually performs when the camera is moving, because in agriculture, almost everything is in motion. Might be on a drone, might be on a machine. So that would be
I think,
question.
yeah. I think it really depends on the time, or basically your real-time demand, right? Of course, the processing for the Quad HDR can be done quite fast, right? But of course, if you really have real-time demand, then you would need to we would need to check whether this is suitable, right? But usually this functionality also should work in dynamic environments.
Okay, thank you for that. Next one is about the IMX 454 and particularly about the spectral separation algorithm for the IMX 454. You mentioned that it needs to run on a host CPU system. So do you actually provide the algorithms also that are used in that software?
Yes, there are some algorithms Sony will provide or can provide together with the sensor.
Okay, thank you. And then there's more of an understanding question about the IMX 454 color filter pattern. You mentioned there's 8 different color filters on top of it. And it's more of an understanding question. Can you confirm that in the end, the the gain of multispectral analysis opportunity with these 8 filters actually comes at a loss of optical resolution.
Physically resolution, yes. So that's true, but there is the opportunity, or like the possibility, to do demosaicing of the image data. So that will lead to a full resolution image afterwards again. So of course you will lose resolution because of the special filtering, but in the end there are demosaicing algorithms which can restore the full resolution of the image sensor.
Okay, thank you very much for that information. Next question goes more in the direction of calibration, and the understanding is that the 454 actually does require a certain level of calibration. And the question, I believe, goes more in Framos direction. Do you offer actually calibration services also for the IMX 454? Maybe Pino, can you take that on?
That's possible. We also evaluate the application and the size and the volume. This calibration needs to be done per unit, so it's something that needs to be considered. But practically, this is kind of a service that we offer on top of the pure distribution. So if that is needed, then for sure we do that. We also do calibration in general. So everything that is needed to integrate a system is welcome.
Okay, thank you very much for that information. Last question for this session today is about the software integration and driver integration. It's about IMX 454 and IMX 900. Both of them have been introduced, let's say, in this talk today. And the question is if they can actually be integrated in common SoCs like an NVIDIA or an NXP. Is that possible, or is there some sophisticated GPU and x86 system required to do the processing?
For sure, we already have IMX 900 integrated on an NVIDIA and on an NXP, so this is already available, and our source code is even on GitHub. For the 454, this is doable. There should be some pre-processing between the host, the SoC, and the sensor, but I've seen some applications that are using the data on the Raspberry Pi, so that was an interesting use case. And yeah, so definitely there's no limit in that direction.
Okay, thank you very much for that. Thanks for all your good questions from the audience, and also thanks a lot for the answers from the speakers. Then with that, let me thank you for the attention during this webinar today. Please keep in mind our upcoming webinars also during autumn. On November 4th, we're going to learn more about HDR imaging unraveled. And on November 13th, shortly after, we're going to learn about low noise imaging for sports analytics together with Sony. If you would like to contact Framos, please scan the QR code and fill the contact form at the homepage. Thank you very much, everyone, for your attention. And with that, we'll wrap things up for today. Have a good day, everyone. Bye-bye.
Thank you.
Bye.